Assalamualaikum and hello everyone. Welcome back to the last video of 4.4 intermolecular force. In this video, what we're going to look at is actually the summary and few examples for intermolecular forces. So on your notes, it will be on page 40. Okay, so let's look here. Okay, so here is the summary. So please write down on your notes itself. So what we have learned is actually there are three intermolecular forces, okay, which is London force, dipole-dipole force and hydrogen bonding. London force and dipole-dipole force, this is what we call as van der Waals forces. Tapi if you want to be more specific lagi, it is London force and dipole-dipole force. Okay, so for the London force, it is for all molecules, be it polar ataupun non-polar molecule. But dipole-dipole force is specifically for polar molecules only. And then last one, we have learned about hydrogen bonding. Hydrogen bonding is between hydrogen and electronegative atom, which is our, it is easier for you to remember is FON, F-O-N. But make sure the hydrogen is bonded to the electronegative atom. So that will be, if the nitrogen ataupun the electronegative atom is not bonded to hydrogen, so it is not a hydrogen bonding. Okay. So for the case of London force and the dipole-dipole force, there are three factors when we're comparing the strength of the intermolecular force, which is the first one is the size. So for a given molecule, first thing first, what we're going to look at is actually for the size dia. So kalau for example, sebenarnya kalau any carbon hydrogen molecule, any organic molecule, hydrocarbon, you have to look at what is the number of carbon. Next, if the molecule has the same molar mass, next we're going to look at is the shape. So yang ini selalunya kalau carbon dengan hydrogen is the same lah. And last but not least is the case of polarity, where for the polar molecule, it has dipole-dipole force kan, and the dipole-dipole force is stronger than the London force. So that's why it has a higher boiling point. Okay, next is actually for the factor of hydrogen bonding. We're going to compare H2O, HF dengan NH3. So when we're comparing these three molecules, first thing first what we're going to look at is actually number of hydrogen bond. H2O ada 4, HF ada 2, and H3 ada 2. Okay, so between hydrogen fluoride and H3, when you compare it, kita akan tengok the case of electronegativity, where F is the most electronegative. Next one is oxygen, and kiranya the least electronegative between these three atoms is nitrogen. Okay. Inilah ataupun senang yang mesti guna ni, SNOF ni. SNOF ni increasing electronegativity. Okay, so that is the summary. So please write it down. Okay, so sebenarnya it is important juga kamu tahu pasal yang polarity ni lah. Polar ni you have to look back on your notes on 4.2. How to determine the polarity, which I will give the link to the playlist in the description. Okay, yang ini pun ada macam a simple summary. Okay, so for example, for a given molecule, first determine whether it polar or non-polar. Because, contohnya, if you know it is non-polar, so it will be easier for you to determine it is actually, it only has London force. London dispersion, dan ada London force sahaja. London force ataupun dispersion force. Buat London force sahajalah. Okay, but then if the molecule is polar, then you have to look whether the hydrogen bonded to the electronegative atom or not. If it's not bonded to, the hydrogen is not bonded to phone, so it only has dipole force. Tapi if the hydrogen bonded to the phone atom, it has hydrogen bonding. So contohnya, what I have here, I'm just gonna write down an example. We have H, C, N. Okay, for this case, remember, this is actually shape dia linear. And then remember, for this case, nak tahu the polar dan non-polar, we have to draw the dipole moment. So dekat sini, okay, between carbon and hydrogen, carbon is more electronegative. Okay, and between carbon and nitrogen, nitrogen is more electronegative. So my head will be towards nitrogen, my tail will be carbon. Okay, kalau arrangement ni boleh tengok kat sini lah yang SNOF ni kan. So overall dipole moment, it will be towards your right. So kat sini dia, it is mu is not equal to 0. Maka it is actually a polar molecule. Okay. Contohnya kat sini lah. It is a polar molecule. Okay, next kita tengok. It can be dipole ataupun hydrogen bonding. Okay, we do have hydrogen, tapi is it bonded to our N, O atau F atom tak? Okay, even though kita nampak HCN ni macam ada kot hydrogen bonding sebab ada N kan. But then the hydrogen is bonded to carbon. Hydrogen is not bonded to nitrogen. So, since the hydrogen is bonded to carbon, hence it is only has dipole-dipole force. So, kat sini dia ada dipole-dipole force. Okay, tapi remember, besides dipole-dipole force, sebenarnya dia ada juga London force. Sebab London force is applicable to all molecule. So, kita kena bagi tahulah dia ada polar pula. Dia ada London force as well. Next, last one is actually order of increasing strength of attraction. So, kita akan arrange in terms of the weakest to the strongest. Okay, so the weakest one will be our London force. Force ni sebab dia is actually a temporary dipole. Dia punya partial positive dengan partial negative tu temporary sahaja. Next one is actually kita punya dipole-dipole force. Okay, and last but not least, the strongest one between all the intermolecular force is hydrogen bonding. Okay, so this is what we call as our intermolecular force. So, contohnya kalau kita ada covalent bond, ionic bond, additive bond tak nak. Okay, ini intermolecular force. Tapi, kalau contohnya, comparekan between intermolecular dengan intramolecular, intermolecular ni is weaker lah than intramolecular. So, contohnya kat sini kan, kalau kita ada certain soalan yang kadang suka tanya. Okay, so this is between intermolecular force. So, contohnya kalau kita ada ionic bond dengan additive, dengan covalent bond, mana kita nak letak? So, sebenarnya, covalent bond is stronger than our hydrogen bonding. Okay, tapi the strongest one is actually our ionic bond. Sebab ionic bond kita ni memang ada partial positive, memang ada positive negative charge kan. So, it has high electrostatic force of attraction. So, it has the highest lah strength of attraction. Tapi, kalau between the intermolecular force sahaja, London force weakest, dipole-dipole force, hydrogen bonding. Tapi ada certain soalan memang suka tanya lebih sikit. Covalent bond is stronger than hydrogen bonding. Tapi ionic bond is the strongest one. So, that is for your summary. Berapa minit summary. Okay, dekat sini, example number 1. Yang ini, I'm going to give you a Google Form question. Arrange the compound in terms of increasing boiling point. So, explain. So, dekat sini, first thing first, remember lah. Kita nak tahu SSP. Okay, yang itu, please answer the Google Form. Number 2, state the intermolecular force exists between each of the molecule. So, here, dekat sini, is actually the name of the molecule, tapi kita dah belajar pada page 18 dengan 19 kan? Okay, so please refer to this page lah tengok. So, contohnya our CO2. CO2 ni is non-polar molecule. So, when it is a non-polar molecule, what is actually our force? Tadi page kita berapa tah? So, please refer. Is it polar ataupun non-polar? So, bila kamu tahu the polar and non-polar, remember that. So, please remember that for non-polar, it only has London force. Tapi, if it's a polar molecule, it will has London force dengan dipole-dipole force. Okay. So, last but not least, based on VSEPR, predict the molecular geometry of H2O and CH4. Compare the boiling point between H2O and CH4. Explain. Okay, so first thing first, what I'm going to do is predict the molecular geometry of H2O and CH4. Okay, so from here is actually, I have written down, Mr. copy paste, but then what we're going to do is actually, if the question give you this type of question, what we're going to do first is actually you have to draw the Lewis structure. Okay, so to know the valence electron, you have to write down lah the electronic configuration, then count the total valence electron. So first thing first, you can draw the Lewis structure, which does not depend on the sheet itself. But once dia kata predict the molecular geometry, then we know lah, we have to write the class EPG dengan molecular geometry. Include lah sekali bond angle. So once you have written down all this information, then you have to draw the shape. Because Predict the molecular geometry ni, even though dia kata predict, but then you have to explain tau one by one. The step ni semua kena buat. So the same goes for water. Okay, so predict the molecular geometry. So this is actually what I have written down lah. Have to write down electron pair as well as the molecular geometry. Okay, next is actually compare the boiling point between H2O and CH4. So when we're talking about the compare the boiling point, so we're talking about our IMF, intermolecular force. So intermolecular force ni nak tak nak, we have to look based upon our polarity. So for a given molecule, what I'm going to draw right now is the dipole moment. So sebab shape kita dah buat, okay, remember on your notes page 19 I believe. Tak. Ni molecular geometry dah buat. Next, we have to draw the dipole moment to determine the polarity. Remember lah, electron tu, the arrow tu will be towards fluorine, oxygen ataupun nitrogen, or between chlorine, bromine, iodine. So, tengok balik. So, dekat sini, how we gonna do it? How we gonna draw the intermolecular, the polarity? Okay, so between carbon dengan hydrogen, okay, carbon is more electronegative. So kita buatlah arrow towards carbon. Here, the resultant double moment will be upwards, while this one, it will be downwards. Hence, it will be cancelled out. So in this case here, mu is equal to 0. So since it is mu equal to 0, it means that the dipole moment cancel each other out. Okay. And then kalau for the case of water, remember the arrow will be towards our oxygen. Sebab oxygen is the electronegative atom kan. So buatlah towards oxygen sini. Sini kita buat towards oxygen. Okay, what happened here is that satu towards here, one towards here. So it will not be cancelled out. So kat sini dia akan jadi mu is not equal to 0. Okay. So from here, how do I going to explain it? Okay, kita buat arrow, dah buat yang symbol tu. Next, yang in terms of explain, how to explain it? Okay. So I'm going to write down here that my CH4 is a non-polar molecule. Non-polar because mu is equal to 0. The dipole moment all cancel each other and has London force. Remember, kalau non-polar, London force. Okay, but then water is a polar molecule. Okay, tapi dalam kes ni, dia bukan hanya ada dipole force je tau. Dia sebenarnya ada hydrogen bond. Tengok sini, and has hydrogen bonding. And when you compare the strength of attraction between these two, hydrogen bonding is stronger than London force. Hence, H2O has a higher boiling point than CH4. So, that's it for this video.